So today we are going to learn lesson 7, chapter 7, lesson 7. And the objective of this lesson is that we need to be able to relate the perimeter and area of similar figures. And we need to understand that these two formulas given here, that the perimeter of figure B here is equal to the perimeter of figure A times the scale factor. We are going to review what scale factor is. Okay, so as we go through this lesson, and we're also going to learn that the area of figure B is equal to the figure area of figure A times the square of its scale factor. Okay, so these are the two rules that we will be using for this particular lesson. But let me just modify this rule. I can also say that the perimeter of figure B, okay, which is the bigger figure, is equal to the perimeter of figure A, which is the smaller figure, times the scale factor. See, if you notice, this is your big figure, and this is your small figure. The same manner, the area of figure B, which is your big figure, is equal to the area of figure A, which is your small figure, times the square of the scale factor. So we will be using these two formulas, okay? Uh, we'll be using these two formulas for us to be able to uh, answer all the questions that are being given to us. So let's take a look at example number 1. So in this case, two rectangles are similar. One has a length of 6 inches, a perimeter of 24 inches. The other has a length of 7 inches. What is the perimeter of the rectangle? As promised, said we're going to review what scale factor is. And if you look at, we did this a few lessons ago. So this is the definition of scale factor. Scale factor is the ratio of the lengths of two corresponding sides of two similar polygons. So if you have two similar polygons, okay, so that's going to be the ratio of the corresponding sides. Let's just recall that when you talk about similar polygons are such because the corresponding angles are congruent. So that means the angle A, which is corresponds to angle W, they're congruent by virtue of that single arc. Angle X is congruent to angle B because of the double arc. Angle Y is congruent to angle C because of the triple arc, and angle D is congruent to angle Z because of the 4 arcs. So that's what it takes for them to be similar. Okay, all the angles need to be congruent. Okay, let's go back. So we want to find the scale factor. Okay, from quadrilateral ABCD to quadrilateral WXYZ. So for our own purposes, to be able to find the scale factor or SF, okay, we are going to get the side of the bigger figure. In this case, this is our bigger figure. This is our smaller figure. Okay. YZ right here. Okay. And we are going to look for the side that corresponds to YZ. The side that corresponds to YZ is CD right there. So basically, it's going to be YZ over CD. So our scale factor would be 15 over 10. And we simplify that, that's going to be 3 over 2. Okay? So again, can we switch that around? Can I put CD over YZ as my scale factor? The answer is yes. But for our own purposes, so that we don't want to be confused, let's just stick to this particular rule for this lesson. Now, when you talk about scale factor, it's the length of the bigger, okay, figure over the corresponding length, okay, of the side of the smaller figure. So let's make that into a rule so that we don't get confused of what goes on the numerator and what goes into the denominator. So that's what scale factor is. Okay, so let's go back to our example right here. Two rectangles are similar. One has a length of 6 inches and a perimeter of 24 inches. The other has a length of 7 inches. What is the perimeter of this rectangle? Again, first things first, we need to write down what formula we're going to be using. We're going to be using this formula right there. And I'm going to write it down as the perimeter of the big figure is equal to the perimeter of the small figure multiplied by the scale factor, or SF. Okay, so what do we know? We know that one has a length of 6 inches and a perimeter of 24 inches. The other has a length of 7 inches. Okay, we want to find out the perimeter of this rectangle with a length of 7 inches. So let's analyze this. We know for a fact that the rectangle with a length of 6 inches will be the smaller rectangle. Okay, and the perimeter will be the perimeter of the smaller rectangle. So in this case, we know that the perimeter of the smaller rectangle is 24 inches. We don't know what the scale factor is. Again, remember what we talked about in terms of scale factor. We want to get the length of the bigger figure, in this case that's 7, and put it on top the length of the smaller figure, which is 6. So our scale factor is actually 7 over 6. That's how you got that. Okay? So we know that the perimeter of the original, or the smaller rectangle, is 24 inches. So we simply substitute. So to be able to find the perimeter of the big rectangle, we get 24 and multiply that by 7 over 6 right here. Okay? And we cross cancel. That's a 1, that's a 4. We simply multiply 4 times 7. Okay, gives us 28. So the perimeter of the new rectangle, or the bigger rectangle, is 28 inches. Okay? Okay, I hope that makes sense. Let's take a look at the got it and see how this works. You have triangle LMN is similar to triangle PQR. Again, we don't have to worry about if they're similar or not because it's already saying that they're similar to each other. Okay, that means the corresponding sides of both triangles are proportional. If the perimeter of triangle LMN is 64 meters, so the perimeter of this one is 64 meters, and what is the perimeter of triangle PQR? We don't know the perimeter of this particular triangle. Now, we already know that this is our big triangle, our big figure, and this is our small figure. Okay, let's go back to our formula. The perimeter of the big figure is equal to the perimeter of the small figure times the scale factor. We don't know what the scale factor is. We know for a fact, though, okay, that PQ corresponds with LM. That means we can get our scale factor from there. So remember our scale factor now. We get the length of the bigger triangle, which is 24, over the length of our smaller triangle, which is 18. And if we simplify that, okay, 24 over 18, we divide both sides by 6, which is the GCF. This becomes 4 over 3. So the scale factor is 4/3. So going back to our formula, the perimeter of the big triangle is equal to the perimeter of the small triangle. Well, let's substitute. The perimeter of the big triangle is 64. Okay. The perimeter of the small triangle, we don't know. So let's make that still perimeter of small triangle. We know what the scale factor is, which is 4 over 3. And this is a one-step equation. To be able to solve for perimeter of the small triangle, we simply multiply both sides by the reciprocal, which is 3/4. Reciprocal of 4 over 3. And we cross cancel. This one becomes 1. So we're left with the perimeter of the small triangle. This is 1, and this is 16. Multiplied by 3, you get 48. So this is 48 meters. So the perimeter of the small triangle is equal to 48 meters. Okay? Okay, if you don't understand, pause it, rewind, and redo the problem again. Okay, let's take a look at the second example, which is right here. In a scale drawing, the perimeter of the garden is 64 inches. The actual length of AB is 18 feet. What is the perimeter of the actual garden? So basically, this is a scale drawing. This is your small figure, okay? And we know that in actual length, okay, way bigger than what I drew, AB is 18 feet, okay? So this is the small figure, and this is our big figure. So the actual length of AB is 16 feet. What is the perimeter of the actual garden? Okay, now what is given? We know that the perimeter of this scale drawing is 64 inches. Okay, let's take a look at this side note about scale factors. So when you talk about scale factor, when finding the scale factor from one figure to another, the units must be the same. That means they need to be both in feet or they need to be both in inches. Okay, we can either convert 24 inches into feet or convert 18 feet into inches. So the book chooses to convert it into inches. Okay, so the actual length is proportional to the length of the drawing with a ratio of 18 feet over 24 inches. Okay, find the scale factor. So again, our scale factor, okay, is equal to the length of the big figure, which is 18 feet, over the length of the small figure, the corresponding length of the smaller figure, smaller side, which is 24 inches. Okay, again, the units must be the same. So we need to convert 18 feet into inches. So we multiply that by 12, end up with 216 inches. Okay, so now they both have the same unit, which is both in inches now. This now becomes our scale factor, 216 over 24, and if we simplify that, that becomes 9. So the scale factor of this whole thing is 9. So go back to our formula. Our formula simply states that the perimeter of the big figure is equal to the perimeter of the small figure multiplied by the scale factor. Okay? We know that the perimeter of the small figure is 64. We know that the scale factor is 9. Simply multiply 64 times 9 gives us 576. So the perimeter of the actual garden is 576 inches. And if you divide that by 12, we get 48 feet. Okay? So the actual perimeter of the perimeter of the actual garden is actually 48 feet. So this one, this big one right here, will have a perimeter of 48 feet. Okay? Okay, let's do this got it and see if you understand what we just did. So two quilting squares are shown. Scale factor is 3 to 2. What is the perimeter of TUVW or square TUVW? So what do we know? We know a few things here. We know what the scale factor is, which is 3 over 2. So our scale factor is 3 over 2. So we don't have to worry about that. Our formula is perimeter of the big figure equals the perimeter of the small figure multiplied by the scale factor. Okay? For us to be able to find the perimeter of the big figure, we need to find the perimeter of the small figure. Since this is a square, all sides are also 4 inches. And if I want to find the perimeter of my square, this is simply 4 plus 4 plus 4 plus 4, or 4 times 4, which is 16 inches. So the perimeter of my small quilt or my small square is 16 inches. Now let's substitute the values. So the perimeter of my small square is 16, and I simply multiply it by my scale factor, which is 3 over 2. I do my cross canceling. That's a 1, that's an 8. So the perimeter of my big quilt or my big square is equal to 24 inches. Okay? Okay, let's move on to area. Okay? So here, in example 3, we're talking about area and how they relate to each other. The Eddingtons have a 5-foot by 8-foot porch in front of their house. They are building a similar porch in the back with double the dimensions. Find the area of the back porch. So let me simplify the drawing for you because that drawing is quite confusing. So this is, okay, thank goodness for automatic straight. So this is the front porch, and it has a 5-foot. Dimensions are 8 feet and 5 feet. Okay, that's a rectangle. Now let's assume that's a rectangle. Okay, so they want to make it, they want to do a similar porch in the backyard, which has which is going to be our bigger rectangle. Okay, so this is going to be in their back porch. Okay, and what's going to happen is that they're building a similar porch in the back with double the dimensions. Find the area of the back porch. So this is our small figure. This is our big figure right here. So first, we want to find the area of our rectangle. Okay, to be able to find the area of a rectangle, we know its area equals length times width. Okay, which is equal to 5 times 8, or 40. So the area of my small rectangle is 40. But the formula for finding the area of my big figure is equal to the area of my small figure multiplied by the scale factor squared. Okay, that's the formula that we came up with on page 570. So we know for a fact that the scale factor is 2. Where are we getting 2? Because it says double the dimensions. They want to build a similar porch in the back with double the dimensions. So the scale factor is 2. Double means 2 times. Okay, so square 2 multiplied by 40. We substitute the values. 40 times 4 gives us 160. So the back porch will have an area of 160 square feet. Okay, and let's take a look at this last. Got it. Malia, okay, is painting a mural on her bedroom. Okay, the image she is reproducing is 4.8 inches by 7.2 inches. If the dimensions of the mural are 10 times the dimensions of the image, find the area of the mural in square inches. Let's analyze this problem. So basically, Malia is painting a mural. A mural is basically a huge painting. So that's your mural, and this is your little painting right here. So Malia is painting a mural in her bedroom. The image she is reproducing is 4 inches by 7.2 inches. So basically, this is 4.8 inches by 7.2 inches. Well, it's probably the other way around, since this is longer. So this is 7.2 and this is 4.8. Doesn't really matter. Okay. And she is reproducing that mural. So that's your mural right there. Putting it on her bedroom, making it big. If the dimensions of the mural are 10 times the dimensions of the image, find the area of the mural in square inches. Okay. Again, let's look at the formula. Formula that we are going to be using here will be the area of the big figure is equal to the area of the small figure times the scale factor squared. So first things first, we need to find the area of our small figure. So the area of our small figure is length times width, or 4.8 times 7.2. So the area of our small figure is actually equal to 4.8 times 7.2, which is equal to, hold on, 4.8 times 7.2. Let me use my calculator here. 4.8 times 7.2 is equal to 34.56. Okay, square inches. So using that, we know that the area of the big figure now, or the mural, will be 34.56 times the scale factor. Now, where are we going to find the scale factor? Scale factor is here. It says 10, she wants to make a mural that's 10 times the dimensions of the image. So that's our scale factor. So our scale factor is actually equal to 10. So this is 10 squared. We know that 10 squared, I'm going to put it here, is equal to 100. So the area of our big figure is actually 34.56 times 100. Or the area of the big square is 3,456 square inches. And that is now the area of the mural she wants to reproduce. And that's it for our lesson. Thank you for